What's going on, everybody? Johnny Bannon here at Trepa Technologies, and in today's video we're going to be going over domain 2.3.2, which is our second part of our wireless section. This is going to go into encryption, pre-shared keys versus enterprise mode, which is going to be the same whether we're doing WPA2, WPA3. We're going to go over autonomous and also lightweight access points, and then also touch on captive portals, which I'm sure we've all used. If you've ever been to an airport, coffee shop, captive portals is something that public areas, public businesses, or businesses that are very open to the public like to use to give themselves some sort of protection. So that being said, let's go ahead and get started. Let me get my face out of the way here, and let's jump right into it. Okay, so encryption. We're going to go over two types of encryption standards for Wi-Fi. So WPA, Wi-Fi Protected Access. The history of encryption, to be brief, it started with just open authentication, which just meant that in the 802.11 frame, we joined an access point, but there was no authentication method to it. Then WEP came out, which I think, in the late 90s, early 2000s, that became almost deprecated. And then Wi-Fi Protected Access came out, WPA. And that was the first good encryption standard, I guess you could say, that we had. WPA used TKIP, and it also allowed for pre-shared keys and enterprise mode, which we're going to get into. And then WPA2 came out, and it uses AES encryption with CCMP for the cipher mode. Okay, so I think it's counter cipher mode protocol. Okay, it went up to 128 bits. So WPA2 uses 128-bit AES encryption, still secure. Okay. And then we had two modes of WPA2, how we could deploy it. So if we had a SOHO, small office, home office environment, a couple access points, maybe a couple access points meshed together, 10 to 20 users, not even, less than 10, less than 15 users, we did WPA2 personal, where we just had a pre-shared key, which is going to be what you're used to. That's you selecting an SSID on your laptop or your phone, and then putting in a password. But we call it pre-shared keys, okay? In Wi-Fi vernacular. Then we have WPA2 Enterprise. So Enterprise is when we need something more robust. We're going to have big enterprises, big campus networks, big office buildings. You work at a big bank. Really any industry that has really you want to start using Enterprise the moment you have actual accounts to log in, you have a domain, right? That's Enterprise mode. That's where you access the Wi-Fi with the username and password. And there's going to be a AAA protocol, more advanced authorization and accounting with WPA2 Enterprise, or just the Enterprise mode. So that's in Enterprise networks. It uses a centralized authentication server using a protocol like Radius in conjunction with maybe like 802.1x to manage access on a per user basis. This is you logging in with the username and password when getting on the Wi-Fi. That's what it would look like to a user. So administrators in the back end, right? That's us managing maybe like Cisco ICE, some sort of Radius server that's doing like Active Directory LDAP synchronization even. But now even the cloud. Anyways, not to get too distracted. The newest, most secure and newest encryption standard for Wi-Fi. That's WPA3. I believe it came out in 2018, I want to say, but it had some advances. One, it uses AES encryption up to 256 bits. So we have the increased bit key length. That's going to give us better security. For our pre-shared keys, for our, PSK mode, personal mode, sometimes what it's called, when you type in a password, we have some advanced protection standards on there as well, where we introduced something called simultaneous authentication of equals. We used SAE for authentication, which prevents attackers from guessing passwords through brute force attacks. It gave us perfect forward secrecy, okay, where, not to get too nitty-gritty, and we don't have to, this is just Net Plus, but essentially with SAE, it made it harder for us to do packet captures and do brute force attacks during that transmission process of personal mode, putting in that pre-shared key, okay? Now you may be wondering, okay, you keep saying SAE, but I thought AES was the encryption. You're right. AES is the encryption. That's when we turn plain text into ciphertext. That's when we do, we change what we can see into something we can't see. That's encryption. SAE is authentication. That's helping our authentication process, okay, not be brute force, all right? A little different than just straight up encryption. Okay, but again, it's all ties together. When we say Wi-Fi encryption, what makes WPA3 better? Simultaneous authentication equals, right? It's something that's an added protection to prevent against brute force attacks. It gives us forward secrecy. So WPA3 ensures that even if data from a session is compromised, the attacker cannot decrypt future sessions or previous ones. That's during our authentication process, not necessarily the encryption that we're going to use for like our data frames, okay? But then again, we have enhanced encryption. AES up to 256 bits. And for our cipher suite, or cipher mode, whatever you want to call it, we use GCMP. Galileo's, I think I'm saying that right, counter mode protocol, okay? So we have that enhanced encryption. And yes, of course, WPA3 does personal mode, PSK, and enterprise mode. No difference there. Enterprise mode in WPA3 is the same as it would be in WPA2. It just has the advanced encryption and SAE and extra protections, okay? Okay, guest networks. So let's say we run a coffee shop, very common example, hotel, and we have people coming in and out that aren't users. They're not like employees on an enterprise, but we need to give them access to the network without compromising us, leaving it wide open. We can have captive portals where we say, hey, yeah, you can log onto our Wi-Fi, but you need to come get a code from us. That isn't a pre-shared key. Maybe you need to buy something from our coffee shop. We print out a receipt that says, okay, here's your unique code for 2 hours. Maybe in a hotel room, it's your last name and your room number, okay? So kind of an integrated system where you check in the hotel, and from that system, whatever that point of sale system is that registers someone getting into the hotel, it also talks to our Wi-Fi network, our wireless network, and says, this person can get granted access to our wireless network. And when you come to that captive portal, we're going to be able to see that it was you that logged in, and maybe we can say only 2 people can use this login. So we can do advanced features like that. So guest networks help ensure that external users do not pose security risks to the internal network while providing internet access. Segmentation as well, before I move on, because guest networks, yes, captive portals, but you can have an access point broadcasting multiple SSIDs that correlate to a wireless network. Yes, SSIDs actually correlate to a wireless network that could be segmented in that switched environment via VLAN with its own broadcast domain, its own subnet, and so forth, right? So we can have an access point in our lobby of our big office building that the receptionist needs to get access to the regular network, which could be like an SSID corporate Wi-Fi. But that same access point in that lobby could also be broadcasting maybe on 2.4 gigahertz, just a single band, a get Wi-Fi guest network. And that leads into a captive portal where that receptionist accessing the corporate enterprise, the corporate SSID, puts in a username and password. So we can have that kind of complexity in our wireless networks. Okay, PSK versus enterprise. I kind of already really talked about this already, but pre-shared key, PSK mode, or personal mode sometimes it's called, just single password, shared amongst all users. At your house, you change your Wi-Fi password. That's the password for everybody accessing your Wi-Fi at home. Enterprise mode is exactly like it says. It's for the enterprise network. We have a Radius server, or really just an authentication authorization server that could be tied into a more robust enterprise, like domain controllers, ADUC, LDAP, all that. But it that enforces security policies. It can enforce different permissions, authorizations. It can also do accounting, because Radius is what we call a AAA protocol. So if enterprise, we can provide authentication, a user putting in username and password that we manage, that credential. And then authorization, setting permissions on what that user can or cannot access, right? And then accounting, we can get our auditing with that user. So a user logs in, username and password, to our Wi-Fi, our wireless network. We can have that AAA advanced security, right? We authenticate it, we authorize it, and we audit it. And when we're setting up our access points, we have to ensure if we want those capabilities to have a Radius server, have a AAA server, .1x, Active Directory in the back end, something set up already, and then that access point can act as what we call the supplicant when it receives that username and password. Okay, now let's get into antennas. So we have access points. We know that access points at bare minimum propagate an RF signal or Wi-Fi signal that Wi-Fi enabled devices can connect to using their Wi-Fi radio antenna that's in their cell phone or laptop. But we have different antenna types that serve different purposes. So omnidirectional antenna is going to be what you're used to seeing probably in a regular enterprise. Your junior network admin setting up some WAPs, wireless access points, probably going to be omnidirectional antennas in that access point, okay? I'm going to pause the video and go pull one up for you guys. Just give me 1 second. Okay, I'm going to expand my face here. So here, this is a Cisco access point that I use in like my home labs and our in-person CCNA courses. Inside of here, I wish I had time to screw this off. You can see we can unscrew it here. But there's going to be antennas in here, okay? Radio antennas. They're going to be omnidirectional, okay? Another access point here, okay? This is another, and it's an older one, right? You can go buy these eBay, whatever, right, for your home labs. You can actually set up a wireless LAN controller in EVNG simulation software. It's awesome. Emulation software, really. But in here, this is what an access point looks like, but there are antennas in there, okay? These are regular access points going in your medium to big size offices, okay? Now, what's on this screen here, though? This is what an omnidirectional antenna looks like. And that's probably maybe an access point, but just a straight up antenna that can be attached to an access point. So you kind of have those kind of things. Omnidirectional antenna transmits signals in 360 degrees, okay? So benefits. If I'm in an office and I put this access point, on the ceiling, it's going to come to all my users, right? It's going to come down to everybody. But disadvantages, obviously it attenuates faster. And what we mean by that is it's not going to go as far. The distance won't be as far no matter how much power and wattage we push to that access point, right? Because it's omnidirectional. You can't concentrate the signal, okay? Now, if we look at like a parabolic antenna or a directional antenna, you can see that these are built to go one direction. Now, you see a lot of times directional antennas used to cover long distance using a Wi-Fi signal. So Ubiquiti has a product called Air Fiber, where you can go up to miles as long as you have 2 line-of-sight antennas, and they have directional antennas at the end that you can sync up. You'll beep. It's pretty awesome when it gets a good signal. You can get like 1.3 gigabits of speed through those directional antennas. So the advantage is you go a long distance. This is big time when in rural areas, airfields, directional antennas connecting different sites together through Wi-Fi signals, right? But it's only one direction. So maybe an example of this, you want to push something out to a parking lot. You could have multiple unidirectional antennas on the building facing outward. Now, that's not recommended for security at all. But just saying something you could do, right, from the business perspective. Okay, now I think the last thing we're going to go over here is the different types of access points we have. So we have autonomous versus lightweight. So autonomous access points is going to be what you're used to at the house. When the ISP comes in, gives you that single device that's a modem, access point router, and switch and firewall all in one, we call it an autonomous access point. It's a standalone device that's going to propagate the Wi-Fi signals. It's going to do the routing, be connected to a modem, and send traffic out to the ISP. And small office, home office environments, autonomous access points are great because that may be all you need. Now, disadvantage, it's obvious, the scalability. You don't get as much control over it. Typically, autonomous access points are not feature rich, right? They're not feature dense, okay? Now, obviously, it depends. Like Ubiquiti, I'm going to talk about them a lot because I feel like they're a great product for like at-home networking with some advanced features. They have a product that does access point. It has a lot of advanced features in it, but you can't scale it. Autonomous access points do not scale well in anything large, right? My office building is 2,000 square feet. If I had one access point in a 2,000 square foot office, that may work, but at the edges, it's going to be horrible signal. If I try to put up another autonomous access point, well, it's autonomous. Does that mean I need another ISP connection? Not always. We can mesh that together, but you see where the scaling problem gets. Imagine if I put 20 autonomous access points in an office building, I had to manage all those individually. Just crazy, right? You don't get that centralized control beyond just one autonomous access point, right? The moment you put another one in there, you got to go individually and control those. Now contrast that, and here you see they're trying to mesh here. That's my drawing, the meshing, right? Now contrast that with lightweight access points. Lightweight access points are also very similar to cloud-based access points. I'm going to explain what lightweight is and touch on cloud-based. But lightweight access points are just there to send out and propagate a Wi-Fi signal. They're there to connect Wi-Fi enabled devices back to the distributed backbone switched Ethernet environment, okay? They scale. So lightweight access points rely on a centralized controller to manage hundreds or thousands, depending on how beefy that wireless LAN controller is, lightweight access points that could all have roaming enabled. That could be propagating the same SSID, the same wireless networks. So lightweight access points have that centralized view, that single pane of glass control over potentially thousands of access points from a single server called a wireless LAN controller. So the advantages: one, the scalability. Obviously, if we're going to set up a wireless environment for an airport, we're going to have huge architecture that we're going to take a lot of time to design, right? Or a decent amount of time to design. We're going to have lightweight access points, right? That are being controlled by a couple of WLCs more than likely. Okay? Now, disadvantages. Obviously, the complexity. You're going to need a nice seasoned network engineer, wireless network engineer, to set up big Wi-Fi deployments, right? And then a higher cost, obviously. If we just have a small office, we don't need to do lightweight access points. It just may not make sense. Okay, awesome. So let's do our quiz now. Okay, so where we left off, let's go to our LMS. We'll save and exit here. Let's go to our lessons, and this is going to be in week 2, domain 2.3.2. Let's go ahead and take our quiz. All right. So question 1. Which authentication method is typically used with WPA2 and home networks? That's going to be pre-shared keys, I do believe. We have our explanation there. We want to check it out. Question 2. What is the primary advantage of using a lightweight access point over an autonomous access point? Centralized management, and you can scale them. It's easier to scale. No, you can scale them. I guess it's possible with autonomous, but it's not something we scale. Question 3. Which of the following methods is commonly used to authenticate users on guest networks, especially in public places like airports or coffee shops? Let's go. That's a captive portal, guys. Which of the following is a major improvement introduced by WPA3 over WPA2? Coupled 2 true answers here, right? But I believe we're going to go with SAE. That's because we had AES in WPA2, right? So maybe I might clean that question up a little bit because it's a little trick question, right? Question 5. Which antenna type is best suited for providing wireless coverage in all directions? An omnidirectional antenna. Question 6. Which of the following best describes the difference between WPA2 Enterprise and WPA2 Personal? I believe it's going to be A, because everything else just doesn't make sense. Yeah, WPA2 Enterprise requires a centralized authentication server like a AAA, Radius, DACX server, something. And WPA2 Personal, or PSK, the other name for it, just uses a password, a pre-shared key. All right, awesome. That's 100%. I want to thank you all for viewing. Please feel free to like and subscribe, share with your friends. And if you're interested in getting access to our learning management system, we have bonus videos, all these different practice questions, flashcards, again, bonus content. Click that link in the description below and reach out to our team. Thank you for viewing.